I divided my presentation into two parts. At the first part, I will present some basic information about STEM education, including the concept of STEM, why encourage STEM education, STEM integration, the relationship between STEM education and 21st century skills. Then I will exemplify a STEM class in my teaching context. According to Australia Education Council, STEM education is a term used to refer to the teaching of the disciplines with science, technology, engineering, and mathematics, and also to a cross-disciplinary approach to teach that increasing student interest in STEM-related fields and promote students' development of 21st century skills of problem solving, critical analysis, and creative thinking. Growing concern about STEM education is to remain viable and competitive in the global economy. For example, in Australia, over the next 5 years, employment is predicted to increase in professional, scientific, and technical service by 14%. STEM-related jobs such as ICT professionals and engineering have grown at about 1.5 times the rate of other jobs in recent years. International research shows that building STEM capacity across the population is critical in helping to support innovation and productivity. STEM education offers students one of the best opportunities to experience learning in a real situation. By undertaking real-world problems or projects, applying knowledge and skills from 2 or more disciplines to shape the learning experience, rather than to learn bits and pieces and then to have to assimilate them at a later time. Therefore, in a STEM education classroom, students should be able to perform as problem solvers, innovators, inventors, logical thinkers, and also be able to understand and develop the skills needed, self-reliance, and technological literacy. This graph illustrates the proposed conceptual framework for integrated STEM education. The image presents a block and a tankle of 4 pulleys to lift a load, in this case, situated STEM learning. Block and tankle is a pulley system that helps generate a mechanical advantage to lift loads easier. The illustration connects the situated learning, engineering design, scientific inquiry, technological literacy, and mathematical thinking as an integrated system. Each pulley in the system connects the common practices with the 4 STEM disciplines and are bound by the rope of community of practice. A complex relationship of the pulley system must work in harmony to ensure the integration of the entire system. The 4 demands of integrated STEM do not need to occur during every STEM learning experience, but STEM educators should have a strong understanding of the relationship that can be established across domains and by engaging a community of practice. There is a worldwide agreement that learners need skills such as critical thinking, the ability to communicate effectively, innovate, and solve problems through negotiation and collaboration, may contribute to the development and mastering of 21st century capacity and skills, and advance the quality of learning. Therefore, the pedagogy for the 21st century needs to adapt to the future inquiry, particularly the science. The STEM pedagogies should emphasize project and problem-based learning, encourage collaboration, creative thinking, design real-world learning activities, and engage and motivate learners. Because I don't have teaching experience in STEM education, I give an example. I told my nephew ramps and friction knowledge when we played car race when he was 5 years old. I prepared three materials to test and 4 ramps available. Leave 1 ramp free of materials as a test ramp. Set up the ramps with stairs, gather our cars. Before race, I let him to test out angles at this point. Which ramp angles are faster or slower? Which cars move faster? Heavier, lighter, longer or shorter cars move at different speeds. This is a great way to let him to think about the ways things move. Move on to the texture ramps. I let him feel the texture and describe them. Then I asked him a lot of questions. Before we test out the cars, I let him guess which texture might slow down the car or speed it up as it goes down the ramp. Make predictions on which cars will go faster or slower. We race car down the different ramps and we use a mirror tape to see how far the cars travel off the ramp. Which car goes the farthest? Which car is the slowest? If his guess is correct. This is a project-based teaching and it's engageable and interesting activity. In the process of the activity, my nephew experienced thinking, exploring, problem-solving, and observing what is happening around them, ramps, angles, slopes, and friction. Using mirror tape and mirror how long car ran, and I encouraged him to explain why the car ran different lengths. Combination science knowledge with mathematical measurement. In addition, in the process of the game, my nephew collabs with me and communicates there with me. From what I have learned in this unit, in my opinion, design thinking and design mind play a significant role in STEM education. Design thinking involves the use of strategies for understanding design needs and opportunities, visualizing and generating creative and innovative ideas, planning and analyzing, evaluating those ideas to best meet the criteria for success. Design minds utilize design thinking to develop the capabilities of the successful and creative 21st century citizens within existing education and learning benchmarks. Therefore, STEM educator needs to explore and utilize design thinking and design mind in STEM pedagogy. That's all my presentation. Thank you.